I wanna be an engineer, so freaking bad. Optimize the things I've always had.
In this lesson, students will be utilizing their knowledge of engineering and science concepts to design and test a bridge on West Point Bridge Designer.
I wanna be on the cover of PC magazine.
This lesson will address the first Colorado physical science standard by showing how forces on different bridge beams change as the bridge's load changes. It will also show the limitations of these forces when a bridge fails. This lesson will also address the second Colorado physical science standard by showing how the strength of different bridge beams changes when the matter making up those beams changes. In addition to the science standards, this lesson will address the standards for technological literacy, with students going through the engineering design process to create their bridges. Finally, this lesson will address the National Educational Technology Standards, with the teacher demonstrating the use of a digital tool to analyze and evaluate a real-life structure.
Next to Pentium machines.
After this lesson, students should be able to design a bridge based on structural and materials engineering principles to meet given design parameters.
Oh, every time I close.
This lesson is a culminating activity meant to tie together the topics of statics and materials. Students should have gone through several lessons or a whole unit on each of these topics before this activity.
Oh, every time I close my eyes.
Welcome to West Point Bridge Designer. Once you've opened a sample bridge design, this will be your screen. The Bridge View screen is outlined in purple. This shows your bridge. The Member screen is outlined in green. This tells us various information about each bridge beam or member. The Materials toolbar at the top of the screen allows you to change the properties of one, several, or all of the bridge beams. You can change the material, cross-sectional area, or shape of the beams. There are also tools to modify the structure of your bridge or make a bridge on your own. You can create beams, connect them with joints, and erase any mistakes. To see a comprehensive cost analysis of your bridge, you can click the Cost Analysis button. To test the bridge with a 5,000-pound truck, click the Run Load Test button. When you run the load test, you can see the members in compression are red and those in tension are blue. If the load fails, you will be able to see the catastrophic results.
Design, yeah.
Time for the students to try. They have to create their own bridge from scratch based on the following criteria. For more advanced students, encourage them to try making a more complicated bridge, like a cable or arch bridge. For the students who are struggling, let them modify one of the existing templates.
An efficient way to quantify.
After the students are done with their bridge, they will answer these questions. The printouts will let you see if they met the design parameters. The questions will allow you to see if they thought through their decisions like good engineers, and if they made the connection from statics to materials. Hopefully, this lesson will show students a clear connection between statics and materials and get them excited about engineering.
I would have a show on Discovery, hoping that everybody in the country would watch me on the HD. I'd probably pull an Orville right in the Wilbur, build a plane and take the rudder and dip it in silver. Give away a few smartphones like Einstein, here have this. Take my protractor out and do some mathematics. It's been a couple years since I've been single, so you can find me working late and living off ho-hos. Brain food for the intelligent. Sometimes I like to compliment myself for being smart, but you can call me brilliant.